All right, last talk of the day, everyone. Thanks, Magno, to be here. We're gonna finish this with Kubernetes security, attacking and defending Kubernetes cluster. There you go. You're all set.
Okay, awesome. Thank you. Yeah. Hello and welcome everyone. Thanks for staying up for this last talk. And yeah, we're gonna talk about Kubernetes security, attacking and defending Kubernetes cluster. Just give me a thumbs up on the chat if you can hear me okay, if you can see the slides okay, just let me know. If you have any issues as well. Yeah. So yeah, my name is Magno Logan. Let's see here. Okay, good. Okay, so yeah, my name is Magno Logan. I work as an information security specialist and senior threat researcher at Trend Micro here in Canada. I'm a member of the Cloud and Container Security Research Team, and I'm also a member of the CNCF Tag Security Team, which is another team from the Cloud Native Computing Foundation who focuses on security issues and problems. I'm not a Kubernetes security expert yet, right? I'm still learning. I started learning and researching about Kubernetes security last year. And I also have a personal blog there at katanasec.com, which I try to publish at least once a month, an article, a technical article once a month. And also I have there all my contact information and also previous talks and videos and slides of my previous presentations. It's all there, so feel free to check it out. Okay, so this is the agenda for today, right? I know it's a little bit extensive, but we'll try to cover everything in the time that we have at 60 minutes, right? I think it's enough for us to talk about it. But before I focus on this agenda, and I asked this question on the Discord chat, and I didn't get a lot of answers though, but like how I need to see and understand how familiar you are with Kubernetes, right? Because it doesn't make sense if I go too deep into the topic and talk about Kubernetes security, but you're not familiar on how Kubernetes works and you don't understand those issues, right? So I'm just going to give a little introduction, a brief introduction about Kubernetes for those who are not familiar. So just bear with me, okay? So yeah, basically Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications, right? So what does that mean, right? So basically, if you know, I'm assuming you know Docker and you've heard about Docker before, at least played with Docker a little bit, right? You have your application, you package that into a container, right? And you tell that to run on a Docker host, right? The problem is when you start scaling that and you have hundreds or thousands of containers and you need to manage those and understand how they're doing, if there are any issues, if they need more resources, if a container stop working, right? It's hard to do that only with Docker, right? So that's when they decided to work on Kubernetes, and the history behind it, it was developed by Google, right? And it's based on internal projects by Google called Borg and Omega, right? It's developed in Go, so it's using Golang, right? Which is very common for new cloud and cloud native technologies to use Go. And today it was donated by Google to the CNCF, and it's maintained today by the CNCF. So the CNCF is the Cloud Native Computing Foundation, which is a sub-foundation of the Linux Foundation, right? And just a fun fact here, right? Kubernetes comes from the Greek word. It comes from Greek, right? The word means helmsman or like pilot, in an analogy for the one that's kind of driving the ship, right? It's not always the captain. So the helmsman might be captain, but sometimes it can be somebody else, right? Okay, everything's fine for now. Okay, good. So one of the things that you need to understand if your organization is thinking about adopting Kubernetes, right? You need to know, like, why should we adopt Kubernetes? And from my perspective, Kubernetes is a very complex system, and it's hard to understand at first, especially if you don't have the background on Linux and all the basics that it uses on containers and everything, right? So it's very easy to make mistakes if you're not following the best practices, right? So it's important to understand that if you're willing to go that route and use Kubernetes in your environment, that you understand the challenges that you might face, you have proper resources and qualified people to work on that cluster and maintain it, right? There are other alternatives to Kubernetes if you want. So Apache Mesos, Docker Swarm is another one. And there is also kind of an enterprise version of Kubernetes that's had OpenShift, right? So you can try that as well. And we're going to talk about other versions of Kubernetes, which are the managed versions from the cloud providers that you can also use, which sometimes it's easier and faster to use for someone that's just starting. And okay, so this slide here, we need to focus on that a little bit because this shows the Kubernetes architecture, right? And we need to understand all the little pieces that work in a Kubernetes cluster and understand what they do, right? So basically, it's the architecture is built on the concept of transient decoupled objects connected together, right? So each of those objects, you are able to change it and develop your own if you want, right? If you want to change the kubelet or the kube proxy, right? You can do that, right? It's not always the case, but that's this possibility of just removing an object and replacing with something else. So let's start on the left side here, which is the control plane architecture, also known as master node, but for inclusive language, I'm just gonna call from now on control plane. So basically what we have here, we have 5 major components, and we can see right away from the diagram that there is a component in the middle that's kind of the proxy of all the communications, not just inside the control plane, but also to the outside, to the worker nodes on the right, okay, so that's the Kube API server, right? And what does that mean? It's basically an API server, right? If you played with web applications and APIs before, that's it. It's an API server, right? That's responsible for exposing and receiving API calls. So that's it receives communication from all those components and sends them around to the right location, right? On the left side, on the bottom left side, you will have the etcd, right? And the etcd is the database or where Kubernetes stores all the information, all the internal information that about your cluster, your nodes, your containers, everything is there, right? So for example, which nodes are part of the cluster, which resources exist on a cluster, everything. So, and it's important to note here that one concept from Kubernetes that's different from other kind of applications is that it uses something called, how can I say, it's called declarative state or desired state, if I'm not wrong. So in a way that your cluster, like you tell your cluster what you want, you don't care how it's gonna do it, right? You say, okay, I want my container running and exposing this port, and it's a web application and it's an image that's stored on Docker Hub, for example, right? You don't care how it's going to do it, but once you store on etcd, right, the other components are going to check that and making sure that, okay, is there a container for like Nginx running on the cluster already? No, there isn't, right? Okay, so we need one because that's what we're seeing here on etcd. etcd is kind of the rule of thumb of my cluster, and whatever it's there, I need to reflect on the actual state of my cluster, right? So that's a very important component here, and we'll go back to etcd in the next slides. On the top left, I have the Kube Controller Manager, right? And the Kube Controller Manager is responsible for many different internal tasks of the cluster, like noticing when one node is not responding, right? When making sure that you have the correct number of pods that you need, right? You can have replicas and different number of pods, and I'll get to the terminology and the concept of pods in the next slide. But that's very important. So it's like a controller. And I'm sorry if there is any manager watching, but like a manager, right? So it doesn't do anything. Basically, the controller manager has subcomponents that are really the ones that control the Kubernetes cluster, right? So you have a controller for pods, you have a controller for services, and all that stuff. But basically, it's a big component with smaller components there as well. You also have on the bottom right there, you have the kube scheduler, which is the one that decides where to execute the pods, right? So once it checks on etcd that there is a pod that needs to run on my cluster, then it's going to look at the available nodes on the right, the worker nodes, which are the ones that run the actual applications of my cluster, and it's going to check which node should I run this pod, right? If node 1 or node 2 they're busy and they have a lot of containers and pods running already, then it's going to try to run that pod on node 3, right? So it checks that. It schedules, actually, it schedules and sends a communication to the kubelet for the kubelet to store the container. But we'll get to that in a second. And on the bottom, on the top right, we have the controller manager, which is the one that interacts with the cloud providers, managing resources such as like load balancer and disk volumes, right? Okay. So we covered the control plane, at least the 5 major components there. And now we're going to talk about the worker nodes. So here in this diagram, I have 3 worker nodes, and each of them, they have a kubelet, a kube proxy, and this kind of computer icon here is basically my container runtime engine, right? So what does it mean? What are those components, right? Basically, the kubelet is responsible for managing the container runtime engine, right? Executing the containers when necessary, and also collecting information from execution information, right? You also have the kube proxy, which manages the communication, the network communication, allowing different containers to talk to each other, right? And also responsible for receiving external requests. And yeah, and at the bottom you have the container runtime, which is actually the engine that executes the containers itself, right? So by default, it was Docker, and I don't know if you heard about the discussion about Docker being deprecated and kind of the internet going crazy about that, which wasn't actually true. Docker wasn't being deprecated. What was being deprecated in Kubernetes was Docker shim, which is basically an extension to support Docker in Kubernetes, because Docker by default, it doesn't follow the OCI, the Open Container Interface, and so it wouldn't be able to run by itself. That's why they created like a shim, they call Docker shim, to be able to run Docker as the default runtime engine in Kubernetes, right? But yeah, Docker is not being deprecated. You can still run, and you'll be able to run your Docker containers on Kubernetes clusters for a long time. But Kubernetes, the runtime engine might change, and it could be the containerd, it can be Cryo, or any other container runtime engine like Podman or something like that. And as I said, like in Kubernetes, pod is the smallest unit that you can have, the smallest deployment unit that can have, and a pod can have 1 or more containers. So I'm going to show that in the next slide here. So basically, here we have some objects. we have like outside of the cluster, we have nodes, right? I showed the worker nodes and also the master node or the control plane, sorry, of the cluster, right? So every node you can basically deploy your applications, right? There is some restrictions about deploying applications on your control plane. That's not recommended, and that's because that's where your main pods, right, your main components of your Kubernetes clusters is running, right? But they also, we don't show on that diagram because it's not also on the official documentation, but the control plane also has a kubelet, a kube proxy, and the runtime engine as well, right? Okay, good. So now, basically here we have the node, which is like your virtual machine. It can be a metal server, it's basically the host of your applications, right? And inside Kubernetes, you can have namespaces. So namespaces are logical separation of objects of projects, right? So think of namespace like a folder for your cluster, for you to be able to organize it and run separate applications or separate projects like dev, QA, and production of the same application, right? It's not like a security boundary. It's not a physical boundary, right? It's just a logical separation there. You can also have deployments in Kubernetes, which is basically an object that helps with scaling, updates, and rollbacks, right? It's like an abstraction, right? And at the bottom there, at the middle there, like the kind of the kernel of the Kubernetes, you have the pod, right? Which I said it's the smallest unit of Kubernetes. You can't deploy a container in Kubernetes without a pod, right? You need a pod, you need the pod object, and then on your pod, that's when you run your containers. And inside those pods, you can either have one container or you can have two or more containers, right? So there is some applications for, in containers, we usually want a container to only run one process, right? And so in this case, I can have a pod running my application, which is just one process of my container, and I can have another container collecting the logs and like data and analytics information of the other container, which we call this other container like a sidecar container, because it has another process, so that I don't have to run two processes on the same container, right? So basically that's that. We also have other objects, right? But I won't be able to cover those here. I cover pod, but there's also like replica sets, daemon sets, stateful sets, all those objects. Each of them, they have a specific kind of characteristic and specific usage, right? You also have jobs and cron jobs, right? Which is basically a container, a job is basically a container that runs only once, and a cron job is basically a container that you can schedule like a cron, right, on Linux, like a cron tab, right, and other objects there. And they're usually created. You have like their YAML files, which is similar to this this file to the right here of the slide, right? And there's many others, right? You can create your own Kubernetes objects if you use CRDs and all that stuff. Okay, that's great. That's a lot of information, but how do I talk to my cluster, right? If I deploy my cluster in the cloud, and how do I talk to it, right? So basically, you can use, similar to Docker, which you have the Docker command line, right? On Kubernetes, you have the kubectl or kubectl or kubectl, however you want to name it, right? Which is basically the CLI that allows you to control Kubernetes, right? So you use that, and inside your Kubernetes folder, you have a file, the config file, that has the information about the certificates and the keys for you to access that cluster, right? So it's very similar to the Docker CLI for Docker containers. So if you have experience with that, you're gonna have it's gonna be easier for you to use kubectl. Okay, now I covered the basic introduction, and I hope everyone has at least an overview of what Kubernetes is and how it works. So before we move on, I just want to mention that I created this GitHub repo on GitHub last year as a way for me to kind of a reference. It was basically a reference for myself to when I was researching Kubernetes and Kubernetes security. And it was basically, I started as a text file, right, in my own computer, and then I decided to share that. And now it has become a big project, and a lot of people are contributing to it. So I call that the awesome Kubernetes security list. But it doesn't have only topics and materials about Kubernetes security. It has materials about Kubernetes itself, and it has some materials about Docker. So I have like books and blogs and videos from other people, other security professionals as well. So I'll leave the link here, and then I'll post that to Discord as well, so that you can start it, you can fork it, and you can also submit a PR if you find an interesting link that's not there. Okay, good. So getting that out of the way, so before we talk about the Kubernetes attacks, right, I'm going to just give a brief overview of what is the MITRE attack framework, which we're going to use in this presentation, right? If you work with security, you probably heard about the MITRE attack framework. If you don't, I really recommend you to do it, right? So basically, the attack framework is a globally accessible knowledge base of our adversary tactics and techniques based on real-world scenarios, right? Real-world observations. It's used as a basis for development of specific threats, for threat modeling and methodology in different sectors. So sometimes people use the MITRE attack framework for kind of the defense part. So they understand, okay, who are my threat actors, what techniques they're using, are they targeting my own my industry sector, like financial sector or government, what they're doing, right? So what are their common like MO, right? Modus operandi, right? So it's very important, and it's widely used in the community. I really recommend anyone can use it. It's free, and you can also contribute to it. So what happened here is that the MITRE published a blog post last year, December last year, calling for help. It was kind of a blog post asking the community for help to create the MITRE attack for containers, right? You have different attack frameworks. You have the enterprise one, you have the cloud one, you have the Linux and Windows, but we didn't have one for containers, right? And MITRE thought was appropriate to create one due to the number of attacks and incidents and like specific techniques for container environments, right? So that was really interesting. We reached out to them since last year, and we decided to collaborate because we work on cloud and container security stuff on a daily basis. We had a lot of data and information and blog posts that we could share to help with that work. But before MITRE posted that that kind of article asking for help, Microsoft had released previously in April last year threat matrix for Kubernetes, and they also released an updated version this year. So I recommend you to take a look. It shows the most common attacks and techniques, the tactics and techniques used on Kubernetes, especially on the Azure environment, right? So using K8s, right, which is the one for Azure. I always mix them up, and they update that. So it shows the techniques, how they're used, and which commands, which tools they can use, and all that stuff. So MITRE also used that kind of threat matrix, which is not an official MITRE matrix. They use that as a baseline to create the MITRE attack for containers, right? Okay, so here we have the official one, the MITRE attack for containers and Kubernetes as well, and we have many different techniques. And our project there in collaboration with MITRE helped create 7 techniques, which 5 of them were kind of improvements of of techniques that already existed, but didn't focus on containers. It didn't have a container perspective, right? And two brand new techniques, right? So brand new ones. So this this official framework, this official matrix was released in April 29th. I don't know if you heard about that already. And there's the blog post on the link below talking about this, all the techniques and explaining them in detail, which I won't go over here. Okay, good. Now let's go to our attack scenario, right? So I created before the MITRE framework, before even I only knew about the first version of the Kubernetes threat matrix by Microsoft. I decided to threat model my Kubernetes environment, right? So basically what I did, I created this diagram, and I know it might be a bit hard to see, but I'll try to read some of the stuff here to you. Based on so we have like kind of swim lanes here, right? And each swim lane from the top to bottom are MITRE tactics, right? So you have initial access, you have execution, privilege escalation, and all that stuff. And then each kind of like bubble there is kind of a step through the attack, right? And we're gonna run through that attack here on the next few slides. So basically you have your Kubernetes cluster, which is misconfigured, right? It's outdated, it has a bad kind of bad permissions, bad RBAC permissions, and you have a exposed web application, right? And that web application has a vulnerability. It's outdated as well. It has a vulnerability, remote command execution vulnerability, right? So if you're running, if you have that scenario, right, you're running a web application that's vulnerable and it's running inside the cluster, what happens, right? What happens when someone compromises that application, right? So if someone can get access to that application and can execute this attack, it will be able, after executing the remote command execution, will be able to probably get a shell inside the container that's running, or the pod that's running your web application, right? So that's when on the execution phase here, the second lane, I have like I can do some recon, right? The attacker can check if they're running on a containerized environment or not, if they're running in Kubernetes. So there are ways to do that, right? And the attack goes on, and I'm gonna show in details on the next few slides here, so I won't cover everything there. But basically, this is the diagram and the threat model that I did, and then I went to the practical scenario to try to prove it, right? Okay, this might work. This is kind of like before the POC, right? And then I did the POC to make sure that, okay, that works, right? And usually on Kubernetes environments, if you have that in your organization, the end goal to most of the attackers, so I'd say like 95 or 99% of the attackers on Kubernetes environments, it is to steal your resources, right? So it's the technique called resource right hijacking. Basically, they steal your resources to mine cryptocurrencies, usually Monero cryptocurrencies, right? So either they compromise your running containers to mine, to run their process of crypto mining, or they deploy new containers for running the crypto miner as well. Or even worse, when they're able to do that, they can break out of the container, right? And sometimes even break out of your cluster and like deploy new instances. If you're running on a cloud environment, they can deploy new instances to that, then use those instances to mine cryptocurrencies. So in this attack here, the first POC that I did with the first kind of exposed web application, it took less than 24 hours for the attackers to. I created the cluster, I exposed the application to the internet, right, through a load balancer, but I didn't post the link anywhere. I didn't publicize it, right? But in less than 24 hours, the attackers were able to find the URL of my application, compromise that application, break out of the cluster, and then deploy huge instances to mine cryptocurrencies, right? Luckily, the whole environment was being monitored, and we detect that. And so we were able to shut down the attack right away and stop that from like having a huge AWS bill, right? So that's what we did here. Okay, so here's my web application. Like, okay, starting the attack, I have basically, this is a Drupal web application, a Drupal CMS, which is running the Drupal version 8.5, which is from 2018, and it has a remote command execution vulnerability, right? So what happens next, right? So yeah, it's exposed to the internet. Someone might find it somehow, right? So in this scenario, we're exploiting the RCE in the CVE 2018-7600 called Drupal Gaddon vulnerability, right? And I use this this exploit from GitHub, right, to be able to get the shell access to the application, right? There are other ways that you can attack a Kubernetes cluster as well. One of those are through exposed dashboard. So Kubernetes used to have a dashboard that was installed by default and set up by default that didn't have proper authentication. Now that's disabled. You need to enable the dashboard on your own on the newest versions, right? And you can also exploit that through the Kube API server, right? So if your API server, which, as I said, it's basically an API server, it's a web application there, right? If that exposed to the internet and it's not properly secure and properly configured, right, then the attacker might be able to even like deploy pods and change information, read secrets, and all that stuff. So one thing to note here is that the Kube API server endpoint is public by default on K8s, right? So if you're using the AWS managed services for Kubernetes, by default, your API server is exposed. So if you do that, you better check it out and make sure that everything else is configured so that you're not running into any kind of trouble there. So yeah, how do I check that, right? How do I know that in the specific URL or the specific IP is running a Kubernetes cluster, right? So one of the things that you can do is reach the API endpoint externally, right? So by default on Kubernetes, the API server runs on port 6443, or on managed services is usually just port 443, which is the HTTPS one, right? So basically using a curl request, right, you can just check and see if there's something running there. And if it's that one of those ports, there's likely the situation that there is a Kubernetes cluster running there, right? Also, another thing that you can see right away on the second URL is that on the URL itself, it shows that it's Amazon and it's running EKS, which is the managed solution for Kubernetes on AWS, right? So you already know, okay, there is a Kubernetes cluster here, right? Okay, so what can you do, right? You understand, you did some reconnaissance, you understand that there's a cluster, there's a web application running there. As I said, you can either exploit that through exposed dashboard, right? If you found it, right? Or one of the most common ones is it's through the web application, right? So if the web application is vulnerable, right, your whole structure might be safe, might be secure, but your web application is outdated or has a vulnerability, wasn't coded properly, then that can also compromise your Kubernetes environment. One of the tools that you can use to automate this kind of reconnaissance and attack and understanding the vulnerabilities on Kubernetes cluster is KubeHunter, right? KubeHunter is developed by Aqua, and it's an open source tool that hunts for like security weaknesses in Kubernetes clusters, right? It was developed to increase the awareness and visibility for security issues, right? And it also already has like 37 vulnerabilities checks. So it detects at least 37 vulnerabilities, and you can add, as open source, right? You can submit new checks for new vulnerabilities. If I recall correctly, it's developed in Python. Yeah. So one of the things, okay, let's say I'm inside the cluster, right? I'm inside the pod, the vulnerable web application pod, which I just got an RC on, right? How do I know? I mean, in a Kubernetes environment, right? If I'm still not sure, right? One of the things that I can check is the environment variables, right? So using this command here, it's really simple to get the Kubernetes environment variables, and all the pods from the Kubernetes cluster will probably have those environment variables. So that will already tell you that you are in a Kubernetes cluster. Another thing to take a look is the service account token. So also every pod will have the service account token inside that directory there, the var run secrets Kubernetes service account, right? So if it's there, right, and you can use that to impersonate your pod and talk to the API server. There's also a tool from GitHub called MI Contained, which is called a container introspection tool, right? It's not just for Kubernetes, it works for Docker as well. And it helps you find out what container runtime is being used, as well as other features available, like what capabilities, what if AppArmor is enabled, if FC Linux is enabled. So it checks all that, right? So it's easier for you to understand, okay, how secure or how insecure is this environment. And okay, like I got a shell inside a pod, right? But what can I do now, right? And everything is going to depend on which kind of access and information and permissions you have from that pod and from that service account that you get from that pod, right? So in this scenario here, we had a misconfigured cluster, as I said, and the pod was running with too much permissions, right? We was running the service account that was running the pod had too much permissions, and was okay. You're able to use that service account to deploy new pods, right? And so one of the ways to break out of your pod and your container here is and kind of like escalate privileges, right? Is doing the container escape and deploying a privileged pod in your cluster as well, which maps to your like the host of your worker node, right? So in this scenario, I use basically this command from Duffy Cooley, which is now working at Isovalent, right? Working with eBPF and all that stuff. And he posted that in 2019 and still works today on most of the environments that are not protected and don't have any kind of pod security policy enabled. So here, right, the kubectl run, like, okay, I downloaded kubectl to my pod and then I ran this command, right? So the kubectl run gets a pod with a container, right? But the overrides arguments like make it different, right? And so on the right side of the slide here, I basically have the same command that he has on his tweet, but broke it down in a easier format for us to see, right? So this overloads the spec with a partial set of values parsed from this JSON, right? And we can see that this is a JSON file here. So we see that the host PID equals true here on the top, right? And this breaks the most fundamental isolation of containers, right? Letting us see all the processes as if we were on the host, right? And then the spec here, I start running a container, right? So you use inside this container, I'm using Alpine, right? Which is a very common, a very small Linux container. But then, oops, sorry, my bad. So here on this, I'm executing this command, right? Ncenter, right? And this command is to switch to a different mount namespace, right? And basically, so I think I just have a little bit of time, and I want to talk about the defenses. But basically, here I'm able to deploy this container. Now I have access to my worker node, whatever worker node that the pod is running in, right? So I kind of broke out of the cluster already, and then I can probably compromise the control plane, right? And also maybe even before that, inside the pod itself, right? It's possible to make requests to the instance metadata API, right? If you heard about that, the cloud instance metadata, where you can get sensitive information and sometimes even like access keys and private and API keys from AWS, Google, or Azure, right? You can get that information from the pod already, just making a curl request to that proper IP or URL, right? So here, like this privileged security context, right? It's very important, right? So you need to understand that you shouldn't allow any kind of service accounts or pods or anyone to be able to deploy a pod in your cluster, right? So you need to talk about that. So here we're going to focus now on the defense part. Okay, how can I protect my cluster from attackers, right? Isn't Kubernetes secure by default? And where do I start? I know I only have kind of a few minutes, but bear with me here. Okay, so basically one of the things, as I mentioned, right, that you need to worry about is your Kube API server, right? If your Kube API server is exposed, someone can make just a simple curl request to it on the proper location, the proper IP, and proper port, and it might get an information like that, even if it's like a 403, right, forbidden, right? I know that from the format of this response, I already know that there is a Kubernetes cluster running there, right? So make sure that if you don't need to expose your API server, don't do it, right? If you're having any issues or your applications are not working, make sure that your Kubernetes is only internally accessed or through a VPN or something like that, because attackers are kind of scanning the internet, right? You will have multiple tools like Shodan, Senses, and Binary Edge, and also the attackers are doing their own tools, they're using their own scanners, and they're looking for that. They're looking for exposed Kubernetes clusters on the internet, right? And especially the API server. Another thing that you need to worry about, and I think it's important if you're starting with Kubernetes and you want to follow the best practice, the security best practice, is taking a look at the CIS benchmark. So there is a CIS benchmark for Kubernetes already, and it's like a prescriptive guidance for establishing secure configuration posture for your Kubernetes cluster, right? It has over 120 checks for your cluster, right? So you can check if your cluster is secure, and you can. It's a big document, right? It's a large PDF document, and I know it might be kind of boring to take a look, but it's very detailed, right? It's very detailed in a way that it tells you, okay, you need to have that security setting on your cluster, right? And then it tells you, okay, how to check if that security setting is enabled or not, right? Which result you should expect. And at the end, if that's not enabled, it tells you the proper command and the proper configuration that you need to do to have that setting enabled on your cluster, right? So that's very interesting. It's very detailed. And it was also created by Rory McCune and Liz Rice and among many other contributors. So those are security professionals and cloud native and in Kubernetes security that have a lot of knowledge and experience in that world. So that's really recommended to take a look. And there's also specific benchmarks for EKS and GKE, and I think also AKS should be coming soon, if not already. So yeah, if you're using the managed services from the cloud providers, you can also use that. Yeah, someone mentioned mass scan on the YouTube chat. Yes, mass scan is one of the tools that the attackers are using for scanning the internet for Kubernetes clusters. And I have I released a blog post, I think last month, where they had compromised, a specific threat actor had compromised over 50,000 IPs and environments of Kubernetes clusters, right? So, and how they're doing, it's basically they compromise your environment And once they're internal on your internal network, either on the cloud or on premises, that's when they scan your Kubernetes, your environment for Kubernetes clusters, right? So it's like, okay, yeah, you're not exposing the API server anymore, and you're safe. No, you're not safe if you only do that, right? So they're using a kind of old technique that's a kubelet exploit, but it still works, right? It still works, and it still works for them, and they were able to compromise a lot of clusters like that. Okay, so yeah, moving on. Before we finish here, and then I can talk about other topics on Discord. You also have Kubebench. So Kubebench is another open source tool from Aqua as well. And instead of reading through the documentation of the CIS benchmark, if you don't have time or you don't want to read that, you can just run Kubebench against your cluster, and it's going to check if your Kubernetes is deployed following the CIS best practices, right? It validates your cluster against the CIS Kubernetes benchmark, and it's developed in Golang, right? So that's really interesting. Here's just actually a screenshot of the results of running that Kubebench on my own cluster from this example here. So it was a vulnerable cluster, and it had a lot of bad configurations, right? So we can see from here that it failed a lot of the Kubernetes benchmark checks. Okay, what else can you do on to protect your Kubernetes environment in your containers, right? So one of the main things that I think it's really important is understanding that it always starts from the image that you're running on your Kubernetes cluster, right? If the image is compromised already, then you're gonna have issues, right? It's all about supply chain attacks now, and so you need to understand that before you put that image on your cluster, you need to make sure that it doesn't have any vulnerabilities or malware or any kind of misconfigurations already that might compromise your environment, right? So here I have a list of tools. Some of them are open source or kind of free that you can use to run and scan your images for any kind of vulnerabilities, right? So you even have a command now from Docker, which is Docker scan, which basically uses sneak to check your image for vulnerabilities, right? And I'm not gonna go into that in this. It's not the kind of the goal of this presentation, but if you need more information about those tools, just let me know. Okay, now I scan my image and it looks good, right? And okay, now I put the image in my cluster and it's running, right? But now how do I know if my image gets compromised? For example, in the example that we showed here with the Drupal web application was compromised, right? How would I know? Do I have enough information? Do I have proper logs? Do I have like a runtime protection for Kubernetes? Yes, we do, right? And so Falco, which is also a CNCF project, right? It's kind of the cloud native runtime protection. It's very used as kind of IDS for Kubernetes clusters, right? And the way that Falco runs, it parses the Linux kernel syscalls at runtime. So that's very interesting. One of the developers of Falco was also the developers for Wireshark. If you know him, Loris DiGianni, right? Which Wireshark was previously called Ethereal, right? So he developed that way into tapping to syscalls, and the technology that Falco uses is called eBPF, Enhanced Berkeley Packet Filter, right? And it uses that to detect any kind of unexpected behavior in a cluster, right? So it basically has a rule engine, right? So it's a rule-based engine where you can create rules using YAML to detect any kind of suspicious vulnerability, right? So if there is kind of a shell was executed or a port was open or something like that, someone touched on a specific file that's sensitive, it can generate alerts based on the threats detected, right? So it's very interesting to take a look. It's free and it's open source, and anyone can just install and run it, right? Okay, good. Now we protected the runtime, but what else? Is there any other kind of security setting that I need to know about? Yes, there is, right? There are actually. One of the things is, and we talk about that on when talking about container security, right? We need to limit the resources of your containers, right? Because if your container it's not limited, it's going to request resources if it needs more, right? So like CPU and memory, if you don't have like a threshold or a limit for those, it's going to just keep requesting more resources, and it might even cause you like a denial of service attack, right? So it's important to have that set up on your cluster as well. There is a specific object in Kubernetes called resource quota, where you can apply how much memory and how much CPU you want to give to your containers, and apply that on your cluster level. So that makes things easier, right? Another thing that you need to worry about is it's something called security context. So security context allows you to define like privilege and access control permissions for a pod or a container, right? So some of them that I show here, those are just some examples. There's more kind of features and settings that you can apply, but some of those are kind of the main ones that you need to worry about. So allow privilege escalation, right? What does it mean? This controls whether a process can gain more privileges than its parent process, right? So you don't want that. You don't want to allow privilege escalation. So this should be set to false on your security context. Read-only root file system, right? What does that mean? Defines whether the container has read-only root file system or not, right? So you want that set to true, right? Because the default setting is false, but we recommend setting that to true, because you don't want your container, your root file system of your container being writable, right? And also run as non-root, right? So this setting indicates if the container must run as a non-root user, right? And should be set to true. So I don't want my container running as root, and that's one of the main issues of running containers, right? Is running that as root. Other things that you can do to your pods and your containers as well is using the Linux kernel security features. So the three main ones here that you can enable and set up on your pods is seccomp, AppyArmor, and SE Linux. And I know that I'm almost out of time here, so I'm not gonna talk about that because I don't have I won't go deep into that, so that's not the topic of this presentation. Okay, so I talked about image, right? Talking about controlling the image and protecting and scanning the image in the beginning of before deploying to the cluster, and we talk about the runtime, right? When the container is running already, right? But what about the middle, right? What about in between the container being deployed to the cluster, right? So that's something that we call admission controllers. So one of those admission controllers is called pod security policy, right? But luckily, pod security policy is being deprecated, right? It still is a way for you to apply those security context settings that I showed before in kind of a cluster level, right? But it never went GA, and it was kind of hard to set up. And now they're working on a new version, a replacement for pod security policy that they're just calling pod security. Okay, but what are other ways that I can protect and control the admission of containers, right, and pods inside my cluster, right? So there are some alternatives that you can use. And before this new version of pod security is implemented and released, right, you have at least two main tools to do that. One of the tools is OPA Gatekeeper, which you can use their own language, their Rego language, to define policies and policies as code to tell, okay, is this container running as root? Okay, if it's running as root, then don't allow it don't admit that container into my cluster, right? So that's what the admission controller does, right? And you have the gatekeeper, OPA Gatekeeper here, because Gatekeeper is the implementation of OPA for Kubernetes. And you also have Kyverno or Kyverno, which is basically, it's also a Greek word that means govern, right? It brings like governance and policy for your cluster, and it doesn't require a new language like OPA for like Rego. It only uses YAML files and YAML policies to see and check what's going to inside your cluster in your container. So those are the main ones that you should take a look. How am I doing on time here? Sorry, let me see. Patrick, can you let me know? Let's see the chat. Am I good? Can I keep going, or how we're on time? Okay. Okay, let's keep going. So here you have, please let me know on. Yeah, I can definitely share the slides there, Mike. No problem. And yeah, I gave this presentation before in other conferences as well. If you want to take a look, no problem. But yeah, this is, I think, the largest version that I did with 60 minutes. Usually it's 30 minutes, right? So what is RBAC? And I'll try to cover that briefly before Patrick kicks me out here. But basically, RBAC is called role-based access control, right? And if you use web applications, you understand what role-based access control means, right? Because it's basically you have a role and then you have a set of users that you give that role, and that role gives the users a set of permissions, right? So basically that's what Kubernetes uses as well. It's role-based access control. So it allows you to configure who can access what in your cluster, right? And now on the latest versions, it's enabled by default. You can check that on checking your configurations on your Kube API server. And what RBAC does, it has 4 different objects, right? So I'm going to show here in this next slide that you have an object called role binding and role, right? So role, it's an object that basically contains rules that represent a set of permissions within a namespace. That's why it's a namespace level. As we said in the beginning, namespaces are kind of logical separations of applications and stuff that I want to separate on my cluster, right? So think that as folders, right? And you have role binding, right? And the role binding is basically this object that simply grants the permissions from the role to one or more users, right? And you need to understand here that users can be service accounts, it can be other stuff, because Kubernetes doesn't have users, right? You need to manage that some other way. But you also have cluster role and cluster role binding, which are basically the same thing, but now the permissions are on the cluster level, right? So it's not restricted to a specific namespace, but more like on a cluster level, and those kind of permissions apply. Whatever you give to those users, if you're using cluster role and cluster role binding, it's given to the whole cluster. Also, as I said, etcd is very important for your cluster. It's the main data storage for your storage location, right? All the cluster objects are saved here, right? And as we saw in Shodan earlier this year, there are over 2,600 exposed etcd on Shodan itself, right? Maybe if you look at others like Census and Binary Edge, there might be more. So one of the things that you need to worry about etcd is, okay, the encryption in transit is done by default, right? But etcd is not, the encryption at rest is not done by default. So what happens is all the objects that are stored on that database for your Kubernetes cluster and configuration, they're plain text, right? So anyone can, if they have access to the database, they can read it. Right? So you can do, of course, you can encrypt that, but you need to create an encryption configuration object and tell etcd what do you want to encrypt. It's exactly, right? Do you want to encrypt just secrets? Do you want to encrypt the whole etcd database? What, right? So, but that's not done by default. So that's something that you need to be aware of. Besides that, it's just an example here of how Kubernetes networking works. It's basically just a joke, because a Kubernetes cluster is like a flat network, right? Anyone can talk to anyone. So by default, all the pods can communicate with any other pods in the cluster. And if you work in security, you already know that that's a bad idea, right? That's a bad model to have, right? So the way that you can kind of segmentate the network inside your Kubernetes cluster is through network policies, right? So network policies are basically the policies that you tell, okay, who can talk to who, right? Does the front end really need to talk to the database pod directly, or should it go through the backend first, and only the backend can reach the database, right? Patrick?
Yes.
How long do I have?
It's overtime.
Okay, sounds good. No problem. No problem at all. So yeah, besides network policies, just give me a few seconds and I'll wrap it up.
Awesome, thank you.
Okay. So yeah, besides network policies, you have like a network policy editor if you want. There's also network policies on EKS. You don't use network policies, you use security groups, right? And the last thing that I was going to talk about, it was audit logs, right? So I can share that and talk about more about audit logs because it's not enabled by default on a Kubernetes cluster, and it's very important for you to enable that for security and troubleshooting, right? So and it's kind of it's a bit simple to enable that, right? So yeah, basically the basics of my talk here is, okay, don't forget the basics, right? Update your Kubernetes environment early and often because versions of Kubernetes are released kind of every 3 or 4 months. Don't use cluster admin for your daily work. Treat it like root, right? If you can, use managed Kubernetes services like AKS, EKS, or GKE, right? And check out the CIS benchmark for more security best practices. I hope you enjoyed this presentation. Sorry that I went over time, but if you have any questions around the topic, feel free to reach out to me. And yeah, I'm happy to talk more on Discord. Thank you.
Awesome. Thanks, Magno. Yes, everyone, if you want to join the Discord, there's a Q&A channel. You can continue there. And if you can share the slides, definitely upload them on the Discord or send it to me and we'll upload also to the website. Thanks again, everyone.